In today's session we are going to talk about the topic cloud computing in enterprises. To get an idea about it, we are explaining the basic principle. How does cloud computing actually work? So imagine you have a little clownfish. And your clownfish is called Nemo. You and Nemo are the best friends. You know Nemo since he was a tiny little fish. It was a gift of your favorite granny. But you have only one photo of Nemo. During a birthday party, celebrating Christmas together with Nemo. And of course you really love this fish so much you never want to lose this photo. So you upload your favorite photo on one of your favorite photo websites like Flickr, Facebook or Picasa. And without realizing it, you just started cloud computing. But what does that mean? When you put Nemo's photo online, you can imagine a giant cloud coming down to suck this photo up of the laptop with a straw. Then the photo of Nemo lives in the cloud and you can take it and look at it again. You log on at Flickr or Facebook and there is Nemo. You can see him from wherever you want, from home, from work, even at university, so you don't have to miss him during your lunch break. At first, the cloud seems like magic. But it's not. The photo of Nemo isn't flying around in the sky. Nemo's photo actually lives in a secret warehouse full of computers. These warehouses are called data centers or server farms. They are popping up all over the world. Inside one of the computer's warehouses there are rows and rows of refrigerator-sized computer towers that are way more powerful than your home computer. It's hard to know where exactly your photo of Nemo may be in the cloud. That's because there are such a lot of warehouses. Nemo may be swimming somewhere in Pisa or enjoying the amusement park in Vienna, the capital city of Austria. You just have to trust a web company like Google or Microsoft. They keep Nemo safe. There are a bunch of reasons to do this. The first is that you only have one photo of Nemo. It's on your laptop. And if that laptop breaks or will be destroyed by a hammer or something, or an evil virus is going to kill the memory of your laptop, you are out of luck. No more Nemo, no more memories. But once Nemo is in the cloud, he is stored not just in one place, but all over the places, so you can't lose him. You also can access Nemo's photos from any way. You can send a link to some of your friends so they can see Nemo too. That's just one of the many powers of cloud computing, and it's not just you and Nemo. Entire businesses are running in the cloud. There are plenty of reasons to be scared of the cloud too, but for now you decide to trust the cloud as backup. If Nemo is happy, then you are happy. So how would you define cloud computing? There are many definitions about cloud computing out there. Some define it narrowly as an updated version of utility computing, what basically means that virtual services are available over the internet. Others say that anything you consume that is beyond the firewall is in the cloud. The best definition for cloud computing is the following. It is a technology that outsources application, resources and services in a virtual cloud in the internet. It uses the internet and central remote servers to maintain data and applications. Cloud computing allows consumers and businesses to use applications without installation and access their personal files at any computer that has access to the internet. This technology allows much more efficient computing by centralizing storage, memory, processing and bandwidth.
A fundamental aspect of cloud computing is service orientation. Consumers have the possibility to combine different kinds of services to exactly meet their requirements. To explain the combination options in an easy and understandable way, different models are used. The most commonly used model is the SPI model. SPI stands for Software as a Service, Platform as a Service, and Infrastructure as a Service. Each layer of the model represents one of those services. It shows that everything about depends on the service of the lower layer. Software applications require platforms on which they can be used, and platforms need a kind of infrastructure where they can run on. What if Nemo asks, what is SaaS? I would say SaaS is short for Software as a Service and delivers a single application through the browser to thousands of customers. On the customer side, it means no upfront investment in servers or software licensing, and on the provider side, they have just one app to maintain and costs are low compared to conventional hosting. For example, Google offers a suite of online applications called Google Apps. These include, for example, Google Docs, which allows users to create and share documents online. What if Nemo asks, what is PaaS? I would tell him PaaS stands for Platform as a Service and delivers development environments as a service. You build your own applications that run upon the provider's infrastructure, and they are delivered to your users via the internet from the provider's service. A good example of this type of service is Google App Engine, which is a platform for developing and hosting web applications in Google managed data centers. What if Nemo asks, what is IaaS? I would explain him, IaaS is the abbreviation for Infrastructure as a Service and delivers computer infrastructure as a service along with raw storage and networking. Rather than purchasing server software, data center space or network equipment, clients instead buy those resources as a fully outsourced service. The major example for IaaS is Amazon Elastic Compute Cloud. This allows users to rent virtual computers on which to run their own computer applications.
What else? Well, besides the fact that enterprises can take advantage of different services, we can also differ between three types of clouds. Public, private and hybrid cloud. Which type of cloud should be used depends on the diverse requirements enterprises have. In the concept of a public cloud, the cloud environment is made available to the general public and is owned by an organization selling cloud services. The resources can be accessed over the internet. Private consumers as well as enterprises share the virtual infrastructure. Examples for public clouds are the already explained Amazon Elastic Compute Cloud as well as the Google App Engine. In a private cloud, the cloud infrastructure is operated solely for an organization, like an isolated cloud. It is often located in the own data center of the enterprise. Access can be managed by virtual private networks or the internet. It can only be used by authorized persons like employees, business partners, customers and suppliers of the enterprise. Therefore, this type of cloud is more secure than the public cloud, which can be used from the general public. A hybrid cloud is a combination of public and a private cloud. Parts of the infrastructure are maintained by the enterprise itself, whereas services of public clouds are used as well. Typically, non-critical information is outsourced to the public cloud, while business-critical services and data are kept within control of the organization's private cloud. Are there any benefits and concerns about cloud computing in enterprises? Of course there are. Benefits are, for example, that the applications and data stored in the cloud can be accessed from everywhere. Furthermore, enterprises can save costs for hardware by renting it from the cloud, And another fact is that servers need a lot of space, so some enterprises have to rent separate room to store them, but cloud computing solves this problem. Moreover, money on IT support can be saved as well. Security and privacy are the biggest concerns about cloud computing. The idea of handing over important data to another company worries some people. Corporate executives might hesitate to take advantage of a cloud computing system because they can't keep their company's information under lock and key. The counter-argument to this position is that cloud computing companies live and die with their reputation, so they do everything to protect the data and privacy of their clients. Countermeasures, for example, are access security by authentication authorization mechanism to prove identities. Methods used to realize it are passwords, browser certificates, chip cards, or biometrical measures like iris scan or fingerprints. Physical security is ensured by using physical barriers like walls or fences, or observations are done by cameras. Thanks for watching our video. Hope you enjoyed it.